5.1 in Big Ideas is about finding the nth roots in rational exponents. The question for today is, how can you use a rational exponent to represent a power involving a radical? Couple things we need to remember first. Real nth roots of a. What that means, nth root of a. It says let n be an integer. N must be greater than 1. And let a be a real number. If n is an even integer, then one of these three hold true. If a is less than 0, there's no real nth roots. Remember, that becomes the idea of I. If a equals 0, there's only one real nth root, which is 0. And if a is greater than 0, there are two real nth roots, which means you need a positive and a negative. Now notice it also states there's another way to write an nth rule. A to the 1 over n is equivalent to the nth root of a. Now it says if the number outside the radical is odd. If a is less than 0, it has one answer. If a equals 0, it has one real answer, which is 0. If a is greater than 0, then it only has one real answer. So the big key and the big thing you have to worry about is if the root you're taking is even, you'll have to put a positive and a negative in front of it. Also, if your root is even, if the number inside is not a positive number, it's going to be an imaginary solution. So here we're going to start. The first instructions say, find the indicated real nth roots of a. So I'm going to look at it like what makes sense to me. The nth root, so the third root of negative 216. So what I do is I take my exponent table. I go to where the exponent is a 3. I go down to where I see 216, and I go to the left and it says it's 6. Now be careful because there's a negative inside. That negative means that it needs to be a negative 6. Why is that? Well, what is a negative 6 times a negative 6 times a negative 6? Well, that's negative 216. If we didn't include the negative in it, it would not work. So the answer is negative 6. Let's try another one. The fourth root of 81. So on my chart, I go up to where the exponent's of 4. I go down until I find 81. Then I go to the left and find out it's a base of 3. 3 times 3 times 3 times 3 equals 81. But we have to be careful because this is an even integer. It said if your number is greater than 0, you need to make sure to put a positive and a negative in front of it. Well, why is that? Well, negative 3 times a negative 3 is a positive 9. Times a negative 3 is negative 27. Times a negative 3 is a positive 81. We only need the positive and a negative when the root is even. Moving right along. Let's try a couple more of these. So it says the cube root of negative 125. So I look on my exponent table. I go to where my power or exponent's of 3. I go down to where I find 125. And when I go across, it is 5. Now, can I get a 5, or is it going to have to be something imaginary or weird like that? Well, let's see. 5 times 5 times 5 is 125, but I want a negative 125. Well, the only way to do that is to make them all negative. Because a negative times a negative is a positive, times another negative is a negative, which would give me negative 125. So it's possible to get that negative 125, but you have to use a negative 5. Let's try one more before we move on. The fifth root of 243. Now it's an odd root, so I'm not going to need a positive or negative. So I look on my exponent table, I go to the fifth power, I go down and find that 3 to the fifth is 243. So the fifth root of 243 is 3. There is my missing answer. Now, if we want to go back and look, there was something that I discussed earlier that we really didn't hit on much other than me writing it earlier. Realize, this is something new, that negative 216 to the 1/3 power is the same thing as saying the cube root of negative 216. So my answer would be negative 6. If we look at this one, number 2, 4th root of 81 is the same thing as saying 81 to the 1/4 power, which is positive and negative 3. Looking at 2 more. Cube root of 125 is the same thing as saying negative 125 to the 1/3. And lastly, 5th root of 243 is the same thing as saying 243 to the 1/5 power. Let's change it up. Let's utilize that idea which I kind of briefly talked to you about to figure out some rational exponents. So, the first one we're going to do is 16 to the 3/2. Now, here's what you have to basically remember. You have your base, and then your powers consist of 2 things. The top number's your power, so to speak. Your bottom number's your root. Now, normally, just like with all fractions, we try to do the smaller of the 2 first. So let's look at 16 to the 3/2. Okay, what 16 to the 3/2 really states is 16 to the 1/2 to the 1/3. Well, 16 to the 1/2 is the square root of 16. What's the square root of 16? Well, that's 4, Mrs. Doran. Now, we're not going to worry about putting in positive and negatives here. We're not finding the nth roots. We're just figuring them out. I'm not going to make you do that. But even though it said to the 3rd power, I still need to take it to the 3rd. So it's 4 to the 3rd. 4 to the 3rd is 64. My answer is 64. So, bottom number is your root, top number is your power. So 16 to the 3/2, the root being a 2, is the square root of 16, which is 4. The top number is your power, so it's 4 to the 3rd, which gives you 64. So let's look at the next one. I'm just going to go straight to the roots. It says 32. The denominator is a 5th, so we want the 5th root of 32. 5th root of 32 is 2. Because 2 to the 5th gives me 32. Now it says take that to the negative 3rd power. Well, I know that's the same as saying 1 over 2 to the 3rd, because the negative exponent means you can find the inverse. So that's 1 over 2 to the 3rd, which is 1 over 8. If you'd rather write it with the fractional exponents, it's just 32 to the 1/5 and then to the negative 3rd. Now, Mrs. Dorn, why don't we do the 3rd power first? Well, my problem is 32 to the 3rd is a very large number. And then if I have to find the 5th root of that, it's going to be kind of hard to do. But if I reduce the number as small as possible to begin with, then when I take it to a power, it's not going to be that hard to do. It's easier to reduce and then take the power of versus taking the power of and then reducing by using the root. Let's try a few more. 45 to the 5/2. So first start, 4, the root is a 2. That's a square root. Square root of 4 is 2. Top number is my power, so 2 to the 5th equals 32. There's another one. Don't worry about the negative. Okay, 9 to the negative 1/2. So we're going to find the square root of 9, which is 3. We're going to now take it to the negative 1. Well, negative just means I flip it over. And 3 to the first is 3, so it's 1 over 3. Cruising right along. Next one. 81 to the 3/4. Take your root first. 4th root of 81. 4th root of 81 is 3. Now I have to take it to the power. 3. 3 to the 3rd is 27. Let's try one more. 1 to the 7/8. 8th root of 1 is 1. To the 7th power is still 1. Well, that makes sense. 1 to any power should be 1. We just proved it. Now, will all of them be nice and pretty we can use our exponent table on? No. In that case, you need to use a calculator. So what we're going to do is we're going to use our calculators to find the answers. It says round to 2 decimal places, which is the nearest hundredth. So to enter this in your calculator, depending on what kind of calculator you have, we're going to take 9 raised. Now, if you're using a calculator like my TI-30X2S, you're going to do 1 divided by 5. Or if you like it better, we can write the division symbol. 1 divided by 5. Why is that? There is no 5th root of 9. Nothing times itself 5 times gives you 9. That's a nice, pretty number. 9 raised, parentheses, 1 divided by 5 equals approximately 1.55. So not quite 2, not quite 1, but it makes sense. 9 to the first is 9. 9 to the second is 81. So 9 to the 1/5 is going to be closer to things smaller than 9. Let's try the next one. 12 to the 3/8. If I were to set it up to start with 8th root of 12, nothing's going to come out nice and pretty. So what we do is we just type it in as it says, 12 raised to the 3 divided by 8. Which gives you approximately 2.54. Okay, one more. Now this one looks a little different, but we just have to think about what this means. This says 7, the 4th root. That means the denominator, if it was a fraction, would be a 4. The power is a 3. So really all we're doing is we're taking 7 to the 3/4 power. Now could I do 0.75? Well, yes you can. It is not going to hurt you. Now, why don't we use a nice pretty decimal? Well, 3 divided by 8 is not a pretty decimal for number 12. So 7 raised, parentheses, 3 divided by 4. We get approximately 4.30. Okay, the last concept we're going to do is we're going to solve. In order to solve, we're going to follow some basic rules. Now, we're going to use inverse operations, which means you're going to use, please excuse my dear Aunt Sally. But remember, we're using the inverses, so we're going to have to work backwards. So the first one we're going to do is 4 times x to the 5th equals 128. Now, the easiest way to do these is just to think of it as an x. Well, how would I get the x by itself? Well, it says 4 times x to the 5th. So my first step is going to divide by 4 on both sides. So x to the 5th equals 128 divided by 4, which is 32. Okay, next I need to get rid of my power. Well, the opposite of a 5th power is a 5th root. Why? Because the opposite of a square is a square root. So we're going to take the 5th root of both sides. So we get x equals the 5th root of 32, which on my exponent table it says it's 2. 2 to the 5th gives me 32. Now, I do not need a positive and a negative in front of that 2 because we did not take an even root. If it's an odd root, it's whatever the sign of the number is. Let's try another one, number 15. X minus 3 to the 4th equals 21. So first step we're going to do is we're going to work our way in, peeling away the layers of like an onion. So the first thing I see is the 4th power. So first thing you're going to do is you're going to take the 4th root of both of those sides. Now when I do that, I'm left with x minus 3, because the 4th power and 4th root cancel. And then whatever the 4th root of 21 is in my calculator. Okay, so now how do I get rid of minus 3? Well, I add 3. Well, just like with square roots, we can't add radicals with whole numbers. So the whole number comes first, and then we add the radical. Now, if you want to, you can do your radical first and then add. So what I do is I'm going to hit I'm going to type in 3 plus. I'm going to type in a 4, and I'm going to hit my second and my raise key. It's going to give you a little key like this, and then you're going to type in 21 and press equals, which should give us about 5.14. Now, if you don't like it that way, you can change this 4th root into, say, 21 raised to the 1/4 power. Because remember, the 4th root is the same as the 1/4 power. Could I have done the 4th root of 21, gotten that answer, and added 3 to it? Sure. We're almost done, guys. We have 3 more examples, I believe. So let's try this again. 8x cubed equals 64. Just like the number 14 we did, we're going to start by dividing by 8. 64 divided by 8 is 8. Okay. How to get rid of a cube? Once again, we cube root. Is there a cube root of 8? If there's not, we're going to have to type it in our calculator, but there is. It is 2. Now, I do not need a negative because a negative 2 times a negative 2 times a negative 2 would give me a negative 8, and I don't want a negative 8, I want a positive 8. Okay, that was just like number 14. Now, number 17 is just like what we've been doing, but most people freak out because they see the 1/2. Well, to get rid of multiplying by half, we divide by half. Or you can multiply by the reciprocal, 2 over 1. What happens is the 1/2 and the 2 over 1 cancel, leaving me x to the 5th equals 512 times 2 is 1,024. Well, that's not too bad. All I have to do is the 5th root. I can either do that on my calculator, or I can look it up on my exponent table. If I do it on my calculator, I do 5. I hit my second key. I hit my raise key, and I type in 1024. If I look on my exponent table, I go to the 5th power, and I go down to 1024, and I go across, and I find out the answer is 4. 4 to the 5th power gives me 1024. I don't need a positive and negative because it was not an even root. Okay, last couple. I was wrong. There's 2. And then we'll call it quits for the day. These by far trick up the people the most, so this is why we've got to cover them. Okay, Miss Doran, 18 and 19 look just like a couple we did a couple back. Well, great. So treat them the same way. X plus 5 all to the 4th power equals 16. So the last thing I said is all to the 4th power. So to get rid of all to the 4th power, we're going to take the 4th root of both sides. Well, that's not too bad. That just gives you x plus 5. The 4th root of 16, wait, that's 2. But here's the catch. That's an even root. There's 2 ways to get 16 when multiplying a number times itself 4 times. It's a positive 2 or a negative 2. Well, to get rid of my 5, I got to subtract 5. Let's do a little math here. I have 2 minus 5, which is negative 3. And I have negative 2 minus 5, which is negative 7. Could I have done negative 5 plus or minus 2? Sure. That's just negative 5 plus 2 and negative 5 minus 2. Could I have done x plus 5 equals 2 and just break it up into 2 separate problems like we have in the past and just solved each of those individually? Yes, it will not make a difference. You will still get the same answers. Okay, last one. Here we go. How do I get rid of a cube? I cube root. Okay, that leaves me with x minus 2 equals the cube root of negative 14. Now, if that's a cube root, so we don't need a positive and negative. We would say, hey, it's imaginary, but it's not, okay, because it's an odd root. So you're going to do 3 seconds. You're going to do your raise key and type in negative 14. We're going to go a couple decimal places. That gives me x minus 2 equals negative 2.41. I don't need a positive and a negative. It was an odd root. Add 2 to both sides, and we get x equals negative 0.41. Little bit trickier. Not too bad. Just got to know how to use your calculator. And then, ladies and gentlemen, as I promised, the end.